it to YouTube, and then with that YouTube video in our channel, we can post it onto the forums system.
Okay, I've got it recording now.
Great.
But I should be able to send back the host to you, and I don't know how to do that.
I'm not concerned. I mean, I don't plan on doing anything out of the ordinary here. So if this, just so you guys know, the host has additional buttons that they can do. They can choose to mute everybody. They can choose to unmute. They have certain controls for like bumping people. And so in a more formal context, you'd want to have those controls. This is a pretty informal context, so I'm perfectly happy with just the way it is. So the agenda for today is to go through a show and tell. And the show and tell would be if anybody has been doing anything interesting with 3D printing lately, and if they wanted to go afield of that, that's fine too, talking about those things. Just to go around the group, share some things. And then since this is a 3D printer oriented conversation, if people had questions or ambitions or whatever their, maybe I had some challenges that they were trying to overcome with 3D printing, this would be a forum where we have some expertise and maybe we can get some answers. And then towards the end, we'll just open up for whatever. And the way I'm going to go through this list is using PunchPass, which is the system that we use for scheduling things. Depending upon when someone signed up for a class, they are on a list in a certain order. So I'm just going to go in the order with which people signed up. And that would be starting with, oh, I don't think I should be number one. That just seems wrong. Maybe I was ambitious and wanted to join this thing. Is Darryl out there? Darryl? Nope, not there. Paul, are you out there? Do you have anything you'd like to share with a 3D printing project recently? Or project in general?
No, just downloaded some things from Thingiverse for a Raspberry Pi holder and NEMA 17 stepper motor bracket.
Cool, cool.
It worked out pretty well. Still at baby steps. So that's
hey, Paul, are you planning on using that housing with a Pi 4 or something less?
I don't understand the question.
So there are the Pi versions 2, 3, 4. What I'm asking right now has to do with something I went through recently. Let's see if I've got it here. There are so many Pi holders out there, and yet if you run a Pi 4, it's really a good idea to get one of the housings that you can mount a fan in, because if you look at the performance of the Raspberry Pi as it heats up, it decays really quickly. And I'd say the vast majority of those cases right now don't have fans in them because they really weren't required for the 3, the 3B, any of the prior versions. But the 4 really degrades if you don't have a fan. And so I just wanted to point that out. In the event that you haven't chosen one yet, you might at least look at the options for the ones with a fan if you plan on using a Raspberry Pi 4.
Okay, great. Thanks very much. No, mine was just an Arduino, a bracket to mount an Arduino next adjacent to a breadboard to hold things down instead of gluing it to a base. So
got it. I heard you say Pi in my mind, but I guess you were talking about an Arduino, so never mind.
Yeah, they're all kind of the same, but different. Yeah.
Yeah, right. So next on the list here was Jim. Jim, are you?
Me, Jim, or Jim?
Yeah, you, Jim. Jim Sakura, yeah.
Okay, there's 2 of us.
So do you have any projects that you've done recently? Like for instance, with the last things you did with at the shop, we have the Prusa, which is a filament printer. And then we have the resin printer, which frankly, if everybody doesn't know, the guy who spent 2 months figuring it all out, writing the documentation, doing the training, setting up our space in the shop, that was all Jim. And so he's the one with the most experience in that particular tool. I guess I'm just curious, Jim, if you've done anything since, when you set it up originally.
Well, really the only thing I did in the process of learning, I made a couple of gears for the high school robotics program. And they came out okay. They kind of chew themselves up. So it was more to prove a concept than anything else. And it was the perfect opportunity for me to learn so I could write that complete manual, which I looked at quite a bit when I was in there last, because I can't remember all that stuff.
Yeah.
But one thing I did notice, I had some cracks in my cement, like the member shop had that big hole in the cement, and I patched it up with the resin. I had some cracks in my driveway outside. Now I was in the sun, and all I did was remove the cap.
Yeah.
I didn't have the sunlight go directly into the bottle, but
Yeah.
just kind of the ambient UV light bouncing around, it almost instantly put a very thin layer on the top, and I had trouble pouring it out. I was just amazed that it activated that quickly in the shade, just ambient UV light bouncing around. So that was kind of.
If I remember correctly, correct me if I'm wrong, but it is the UV light that is the curing catalyst, right? That makes it become hard.
Yes.
Okay.
So it's a fun machine to use, and you can make some things that are perhaps more precise than the filament printer. It's a lot more messy, a lot more effort, but for a lot of things, it's just a great little machine. I'm happy with it.
Jim Dallas, I used the 3D printer, the resin printer 2 weeks ago, a follow-up after you did it.
Yes.
Wow, your instructions are perfect.
Oh.
You just follow that, and it's just a straight recipe for doing it. Had no problems at all, and my print turned out excellent.
Okay.
I really applaud your effort to do that. That made a big difference. A question for you. When you designed that gear, did you do that in 360, or how did you do that?
Well, I'm sorry, what the question of what about?
You said you made gears for the robotics. Did you do that in 360, or did you use something else for that?
Oh, well, I have my own copy of SolidWorks, and SolidWorks is a very powerful 3D system. So I do anything for any 3D printing in SolidWorks. And to be honest, I'm not really familiar with other CAD programs that can allow us to make the step files.
Sure. Okay.
Hey, Jim, you've been Jim McGeehan, you've been fun on using the icons for hands up and thumbs up. Are you just commenting on Jim Sikora's efforts?
Yeah, I just, I don't know if the others can see it or not, but you can applaud efforts, or you can say good job. Yeah, that's all right. Did you see the icons come up on your guys' screens?
Yes.
I don't know. Okay.
Yes.
That's all I was doing. Just playing with the features.
And Susan's jumping on board. And Paul, well done, Jim Sikora. Did you have anything else you wanted to say, Jim Sikora?
No, well, I did have one other thing. Our robotics team bought an identical Prusa filament 3D printer.
The Mark III, yeah.
And we have one of the mentors who is quite familiar with it. And one thing that we're doing is when we store the rolls of filament, the reels of filament, we always throw in a bag of desiccant to keep the reels from absorbing moisture, because plastic will expand a little bit when it absorbs moisture. So we try to keep it dry. Even in the cover that we have over our reel, it's not airtight, but it's close to airtight. We have a couple of bags of desiccant just laying in the bottom to try to keep it from going. And we hope that'll keep reduce jam ups because of material filament growing a little bit bigger in diameter. We don't know, it's just an idea we have.
Well, Dallas and I both have built these plastic boxes that have a seal around the rim and small 3D printed holes to guide filament out of. So you keep your filament up to 4 spools in a airtight box, and you put desiccant in there with your 4 rolls, and then only part that's exposed to moisture is the part that's outside. Now, truth is, we actually have all the ingredients to build our own at the shop as well. It's just that we haven't gotten to that yet. So what an ideal audience to ask for a volunteer. It's all there in the cabinet right next to the resin printer. And so if anybody should want to maybe take on an interesting project at some point, the components are there. It just requires, I don't know, an hour of time. And the real reason, and we probably need to figure this out before we actually set it up. Remember how we put those shelves in just above the 3D printers in the digital tools room? The shelf just above the 3D printer was perhaps not quite deep enough to hold the box that would contain the filament. Either that or something else, but something has prevented me from actually following through on that, and probably need to revisit what that something might have been. It may have been just a matter of aesthetics. Maybe it just looked so bad against all that beautiful work to have a big plastic box on the shelf. I'm not sure what the issue was, but we have the box. We should put it into place, because you're absolutely right, Jim, that it can affect the filament. And the way it's affected us in the shop is, you know, that first layer that is so critical to actually stick? When there's too much moisture in the filament, it doesn't stick. And so you end up with failed prints.
Oh.
And we first had this happen to us out in the old location, out in the machine room. And we found that the answer was, we can still use that filament, but we have to put it into a bag for a month with desiccant.
Okay.
And then it comes back to life. And we have quite a few spools. When we got it set up, Dallas bought about 8 spools of different colors. So we actually can rotate things into and out of inventory. But the real solution is probably to do as you said, Jim, put a box up there that has multiple filaments, that has desiccant inside of it. People can then choose the color they want very easily. And it always stays fresh because it's not getting moisture from the air. Anybody else have experience with this topic of moisture in filament? I guess not.
Another possible solution, I know refrigerators are usually very low humidity, so they don't frost up. I don't know if this would be practical or it would even help, but we could put store it in a cold refrigerator. It would not absorb moisture. When it warmed up sitting in the room, I don't know what will happen, but
Yeah.
That's a low humidity environment that it would sit in inside of a refrigerator.
Right. Any other comments on moisture and filament? Okay, thank you, Jim. I see that Darryl joined in, and he doesn't know this, but we already went by his name on the list. So we're gonna cycle back. And before I turn it over to Darryl and ask what he's been doing with 3D printing and what he might contribute to the conversation right here, Jim is the one who picked up the resin printer and got it to the point where we could use it. But he picked it up because it was given to us by Darryl. Darryl was the one who contributed the 3D printer, the resin 3D printer to the shop. And so he may not even be sitting at his computer because it's still muted. But if he is, thank you, Darryl.
Thank you, Darryl.
I guess he's not.
Sure, yeah.
Oh, there you are. Great.
Yeah. I'm at my work computer, which doesn't have a webcam.
Got it.
So I can't go live. But
So Darryl, what have you been up to with 3D printing?
so I got a Ultimaker S5, so that's the big one, because the Prusa was a little small.
Yeah.
The S5 has two print nozzles that, at least from what I'm told, print much better than I tried the Prusa MMU, which prints 5 filaments at a time.
Yeah.
And I could never get it to work. It was, I mean, you have to babysit the whole thing.
Yeah.
And my only interest was printing water soluble. So the S5 does a great job of printing water soluble because then I don't need to print supports. The only downside is that you have to buy the S5 uses 2.3 millimeter filament, nominally 3, which is 2 point something.
Yeah.
And so you have to buy separate filaments for the S5 and separate filaments for the Prusa.
Mm.
Much bigger volume that you can print.
Yeah. Hey, Darryl, from my recollection of early conversations with you on 3D printing, you had some exceptionally interesting use cases that you were pursuing. Is there anything from those endeavors that maybe you can share with the group? Because honestly, they were really intriguing.
Yeah, I can maybe sign in with my phone, which has a camera, but we were printing models of the bones. So the shoulder bones from CT scans. And so that was pretty challenging with the Prusa because the entire blade of the shoulder wouldn't fit inside the Prusa. So I had to chop it
Right.
up. Yeah, chop
Unless it was pediatrics, right?
Right, unless it's pediatrics, yeah. Or mouse scapula. And so, but I printed it really well in the S5, and now we're trying to attach ligaments. So it's mainly for teaching surgeon trainees how to do a shoulder reconstruction. And so this was, it was a learning experience for me also, but it turns out when they actually handle the bones, they have to do it through a keyhole surgery. And so if you do it on patients, you don't really see clearly where you are. And the scapula is so complex that you have a hard time visualizing, where you're drilling. You can do it on a cadaver, but then you've got to strip off all the tissues and the muscle attachments. And then you can't reuse, a cadaver lasts for a few hours. So you can't reuse that specimen over and over again.
And one of the reasons you would have used the water soluble was probably for really clean surfaces and easy structure that didn't leave remnants. Is that the key reason?
Yes. So the blade of the scapula is kind of this triangular shape, but there's no way you can lay it flat on the plate. And so no matter what, all the permutations of orientations I tried, there's a huge amount, 80% of it was support actually.
Wow.
And so it takes me 48 hours on a Prusa to print it, the different parts with supports, then strip them, sand them down, glue them together. And the S5 does it. And the S5 is also, it's not faster than the Prusa, and it slows down because you've got two nozzles now that have to swap out.
Right.
But so far it's worked relatively seamlessly once you get it calibrated.
And that one is a two nozzle, not a filament switching multi-filament technology, right? Two nozzles that are separated by a very consistent distance. So you don't have to actually do these print blocks like they do in the Prusa model.
You don't have to, but if you want, you can. So the Prusa, you have to do it. In the two nozzle, if you're using water soluble, I don't care if the water soluble is a little sloppy because I'm going to take it out anyway. But if you're doing two nozzles with, and you want those two filaments to match perfectly, then you can use a print tower just to wipe out, the stuff that oozes out in between prints.
Right. Right. And is it water soluble that you're using as filament, or is there another?
Yes, I'm using the Ultimaker PVA. So they have their own in-house, just because I was doing it for the first time.
Right.
And with the Prusa, I tried, you gave me a reel of BVOH, and that worked fine as far as water soluble. So I could print it by itself. I could dissolve it. But every time I tried to use the MMU to use it as water soluble support, something would happen because you think about all the events. It has to cut, it has to pull out the filament. Then it has to move a second filament into place. And it extrude that second filament and then print with that. And it's a different temperature. So then pull it out. Every layer, it has to do that. So you can imagine there are so many points of failure that statistically it's impossible, next to impossible to get a print to work.
So I have the four-filament Prusa multi-material unit, and the only reason that it works well is one, they finally got the kinks worked out, but two, unlike your two temperature filament scenario, I always make sure I have exactly the same filaments. So there is no temperature adjustment between layers or between filaments. And I can imagine that would really slow things down for you if your 8PVA and your PLA or whatever you're using were different temperatures,
Right.
especially, I mean, so I can see why you gave that up. It's the same temperature. No, it's not the same temperature in your other 3D printer because you have two heads.
Mm-hmm.
Got it. Okay. Okay. Guys, anybody else printing shoulder blades? No, huh?
But I do like my
I find
resin
it
printer
fascinating.
also. Yeah.
Say that again, please.
I do like my resin printer.
Well, so how are you using that one?
So, I mean, I was just playing with it. So I was making some chess pieces,
Hmm.
and obviously you can get a lot of intricate detail with the resin printer, but the platform is really small and it's limited by the screen size, which I think they're just using cell phone screens,
Yeah, yeah.
cell phone LCD screens. So it's
Yeah.
actually a very clever idea. So they just put a UV layer on top of it. And so the UV filter only allows UV light through. And it's just the LCD brightness is adjusted.
Yeah.
So the advantage is that you can put as many objects as you want and it'll take the same amount of time. It's the layer height that decides the duration, like how long
Right.
it'll take to print. So
Yeah. Yeah. As you're talking about, I'm sorry, was there somebody else? Go ahead, Jane.
Yes. What are you using the shoulder blades for?
yeah, no. Yeah, what was that movie, the one with Bones? I think there was a TV show, right? Bones.
Called Bones, yeah.
Called Bones, yeah. So the movie was Saw. So this particular project, we are teaching surgeon, orthopedic residents how to do shoulder reconstruction. And one of the challenges we have with, I don't know if you've torn a clavicle off your shoulder and the point of your shoulder sticks out. And so that's, it's not a terrible deformity or a disability, but it's a complicated surgery and the failure rate is pretty high. So it's hard to explain to them the biomechanics of how to fix it, and also the surgical technique, because the skin incision is tiny and you've got, the complicated shape of a bone. So the orientation of where they're supposed to drill holes and tie sutures gets difficult. And most surgeons pick that up with practice, but it's a little challenging to let trainees practice on live patients. So they used to do it on cadavers, but you can't use the same cadaver multiple times. It obviously decomposes. So we thought we'll print the bones. We were trying to actually train them virtually on computer models. That's how we started. But surgeons like to feel things. So when they feel things and they can hold things in their hand, it clicks much better than using a mouse and a two-dimensional screen.
Even though there are clicks there too.
Even though there are clicks there.
Well,
Yeah,
that's a really good application.
yeah.
Darryl, was it theoretical that this would be useful, or has it proven to be practical to be useful?
It's actually practical. We did a series of studies where we first CT scanned patients, and we found that different patients have different angles at which you're supposed to direct the reconstruction, because the shape of the bones change. But surgeons are taught just one technique. And so we were able to classify patients into those at high risk and those at low risk, depending on the shapes of the bones. Then we did a cadaver study, and we reconstructed the cadavers in using different techniques and tested them biomechanically. And then we started printing bones to more as a outcome. So how do we now, use what we learned? We published what we found, but somebody has to read it and implement it. And so for, at least at Scripps Hospital, so we train the fellows that want to specialize in shoulder surgery.
Darryl, just a last question. When we start the 3D printing process, we end up we start off with some form of 3D model that we then turn into a G-code file. We're always familiar with the STL format. When you're using a CT scan, what is your workflow from the data there to a format that you can use in a slicer?
So we have a medical imaging software, but you can get open source or free software also that takes, so the CT scan is just slices, images that are going, say, transversely through your body. And on each slice, you can see a cross section of your bone. And so if you take each slice and you segment out the bone, that means you isolate the pixels that form the bone.
Mm-hmm.
You now have a cross section of your bone. You stack these cross sections up. It's actually like slicer in reverse.
Yeah, it's kind of amazing that way. Yeah, yeah.
So, but we have to go through the whole pipeline of going through slicer, because slicer only uses STLs and then cuts them again to create a CT scan.
So you go from slices to a model to slicing again.
Back to slices again.
Wow.
So we're now working on a software control program that will print directly from a medical CT or even an MRI, because you already have the information as slices. So all you have to do is feed it, and the pixels, you have the XY location of the pixel that forms the bone. So all you have to do is give it the XY location. Now, slicer or G code has motion built in.
Right.
Right. So we don't have motion information. We just have location. So
right.
How you go from one pixel to the other. So the simplest way is just to raster.
Yeah.
If you just go row by row, you can do that.
Yeah. Interesting.
So. Yeah.
Anybody else have questions for Darryl? Every time I have a conversation with him about what he's using 3D printers for, I'm kind of blown away. It's really wonderful stuff.
Let me see if I can set up my camera. I have the scapula of the bones.
Yeah, if only you'd had your camera this time, Darryl.
No, I do have my phone. I'll set it up on my.
Oh, okay, great. Yeah, so when we see that,
I'll log in
great.
Again when you
that sounds great.
But I had a question for the rest of you. Is the Shaper Origin has released a workstation, and it's not cheap. It's $450, but it looks, if you look through their marketing hype. Unfortunately, they don't give you a list of features very carefully, but has anybody looked at that to see whether it's worth getting? Because I have the Shaper Origin, and I'm having a hard time setting things up to use it the way it's supposed to.
So Darryl, just because I've built the workstation that they originally made for milling end pieces, and I've looked at the videos of the Shaper Origin workstation, you can tell that it is a more refined and more precise version of a fixture for end milling. $450 seems like quite a bit. They do throw in that Festool box, but my sense was that if you didn't want to make the workstation, given the added clamping and added measuring, that is to say angular placement guides that they put in, it probably works pretty well, because just the plain workstation works fantastically. I was on a video chat the other day, and I just showed some box joints that I did using a wizard, let's call it, an application within the Shaper Origin itself. And it was remarkable how within, I think it was 40 minutes, and it was my first time, but I had done all four sides of a box and they just fit perfectly. And that was because, not so much because of the software, but because that fixture was so good. And that was just one that I had built from their plans. So I suspect that the workstation, especially if you're trying to do small piece work, because with the small piece work, you can use the dominoes that are embedded in that workstation over and over and over again. And they have some really nice clamping options that don't exist in the version that you build yourself. I pulled mine out and did that exercise in part because I wanted to see whether I wanted to spend $450 on it. And I personally concluded, since I had built my own workstation and I was willing to live with the compromises, that I wouldn't get it. But if you don't have a workstation and you're doing small work piece or you're doing end milling, it's probably a really good deal.
Yeah, that's what I was thinking, save the time that I would spend building a workstation. And also it looked very compact. is yours, is the one that you built?
It's very similar in overall dimensions from what I can tell. And yeah, I just take it off of the bench and set it aside, and it takes up very little footprint. You can hang it from the rafters. It's easy to put aside, which is really nice in my small space.
Right, okay. Great.
So
thanks.
you got your camera there?
Almost, yeah.
Okay.
Let me make sure that I'm not.
We're going to be moving on to Mike here in just a second, but before we do that, I wanted to show you guys another feature. If you wouldn't mind just going to the upper right-hand corner of your screen, you'll see that there is an icon. It might say speaker view, or it might look like an array of squares. Those are two different ways that you can look at what's going on. The speaker view has the speaker, where in this case we just have D Lima as a big box. But if you had the other one, you'd have a small icon for each person. You could watch everybody in process. So Darryl, if you have it now, great. If not, we'll go ahead and move on to Mike and come back to you afterwards, okay? That means yes. Oh wait, he's got it. Oh, now this is worth big sizing. Hey, Darryl, take your mute off so we can hear you and so that you grab the screen.
Okay. So this is the shoulder blade. It's too big to fit into a Prusa. And then this is the clavicle. So you can see it's really difficult to figure out how you're going to print this without any supports. Yeah. And this is just a stand, made. And these are the electrical wires that I'm using to show where the ligaments should be and how the reconstruction should work.
Okay.
For different, so it's just a lot easier for surgeons to visualize and explain to them when they get their hands on it. But
Darryl, how do you lay that on the bed? Just those pieces, I'm assuming the clavicle and the blade are done separately. And yeah. How are they on the bed? Can you show us how the orientation?
So the clavicle is like this, but it has to have support all throughout.
Okay.
And then the scapula is tilted a little bit.
So like that angle.
Yeah, at that angle. And then you get support not only between the platform, but also support, over here. So there's lots of overhang,
yeah.
So it takes about 2 days to print the scapula.
Just out of curiosity, do you go through more water-soluble filament than PLA or vice versa?
Yeah, I haven't checked, but I think you're right. It's at least equal, if not more.
Yeah.
There's a lot, yeah.
And the PLA is let's say $20 per kilogram. How much is the water-soluble filament per kilogram?
I think so Ultimaker, everything is more expensive, but it's twice as much.
Only twice as much?
The PVA, yeah.
Oh, okay, good. When I was buying, sorry.
The hard part is keeping it dry. So as Jim was saying, PVA, PLA absorbs moisture, but PVA absorbs it even more.
Yeah. Okay, good.
And then it fits if you try to print. If you try to print it with moisture in it, in the filament, your print head begins to spit. I think the water comes out as steam.
Oh, okay.
You get this, weird spitting.
How rude. That was great, Darryl. Thank you very much.
Sure.
Let's see. Where did he go? Where did Mike go? Oh, there's Mike. Sorry. Go ahead, Mike. Take your mute off and take it away. Tell us what you've been up to.
I'm sitting right here. Haven't been doing too much 3D printing. Most of my 3D printing is with the robotics club that I mentor. So one of the things we did do, since the Prusa 3D printer is a little out of our price range, is we got the Creality Ender 3D printer, which is like $230. So it's much more affordable for a small school that has no money. And then there's just a ton of stuff online for doing upgrades and stuff like that. The 3D printing we've done has been like small grippers that we can power with a servo motor and put on our little robots. So there's that. The other thing that I did that we talked about at the last meeting is the smoke alarm cutoff for the 3D printer. And I actually have the pieces here, so I won't go through it too much because it's pretty straightforward. And I know both you, Travis, and Dallas have built this thing. But if you have,
could you tell us about it? Because I mean, everybody here has a 3D printer likely, and it's nice to know what the solution is. So if you wouldn't mind taking a minute, that'd be great.
Sure. Okay. So I don't know. Does this show up? Yeah. Okay. So this is the basic part. This is a relay. So it plugs into the wall. And then, find the camera. And then you plug your printer into it. And there's, if you look at the thing, it says there's a normally on and always on. So when you turn the thing on, then this outlet will be on. So that's where the printer plugs in. And then the other piece of this is a smoke alarm. So here's a smoke alarm. And what's unique about this is what this is designed for is to have all your smoke alarms tied together. So if one goes off, you know, if you have a big house, they all go off at the same time. So what happens is one of these wires, the black wire you don't use, and then the white wire is common, and then this is a signal. So this signal goes to this little green plug here. And so what happens when the alarm goes off, the relay trips, which turns off this outlet, which turns off the 3D printer. And if you haven't looked at YouTube videos with 3D printer fires, you should, because they do burn. And when they burn, you know, you keep pumping heat into them, and they do have some safety measures where they'll cut off, but there are there's other failure modes where they don't cut off. And so if you can cut the power, then yes, you still probably might have a small fire going, but hopefully it hasn't gotten beyond the 3D printer. But if your 3D printer doesn't shut off and it's sitting on wood or something, then it's not good. So anyway, smoke alarm goes off, it trips this goes off, and then the other piece of this is you want to keep you don't want this to turn off. So you have another piece you plug into it. It's just a 5-volt supply. And this also goes to the same plug here. And since you have two things going to the same plug, you need to have, you know, a diode. You need 2 diodes for each of these lines. And then it's like a one-way valve. So if one goes off, then, you know, it can't see the other one. So, but when this outlet goes off, this outlet goes on. And at that point, if the smoke alarm turns off or whatever, it will stay on. It stays on for the duration. So you would come home and you would see your melted mess, but the power would be off here. And then after you fix the problem, you just cycle the power here, and you're back on again. So it's pretty simple to do. The relay, this thing is like $27. Smoke alarms, $27. Diodes are like $5 for 10. And, you know, I have extras. Dallas has extras, I'm sure, and Travis has extras. So you could probably just get a couple of the diodes, and these little things are like $6. It's really straightforward to do. It's probably a really good idea if you're 3D printing and you're not around, or even if you are around in some other room, it's probably still a good idea. So anyway.
That was really great, Mike. And it's a great example of the kind of thing that can come from a periodic conversation like this, because we should all be aware of an alternative for keeping our 3D printers safe. But more importantly, Mike found this project. Mike built this project. Mike has spare parts for this project. Anybody who wants to build something like this doesn't have to start from scratch. Not only do we have experience, we have some parts. There's a link to an Instructable, or was it a Thingiverse project?
It's
It
a
was Thingiverse,
Thingiverse,
right?
but I have a document that I can post somewhere.
Yeah.
I'm sure there's somewhere to post it.
And that's actually, when we're done with this, I'm going to suggest that, and I'm going to actually appeal to you folks to help me get a 3D printer forum started on our forum system. More details will follow on that, but this video would be posted there. If we could get a picture of the kind of thing that Darryl's been working on to just sort of seed it, your project would be an excellent addition, Mike. And so by having this community, we know each other, we can see what each other is doing, we can learn from one another. And if it can be used to seed a forum session, then even when we're not sitting here on a video chat, we could be out there interacting with other people in the association who are 3D printer enthusiasts. So that was really worthwhile, Mike. Thank you very much.
Okay.
Anything else? Any questions for Mike? Okay. I'm going to take it back now to the next person. Dallas, you're next on the list. If you have anything to say, please go right ahead.
I did have a question for Mike. Where did you get the black electrical box that you started showing us?
Amazon.
Okay, and
so it's called a, let's see.
Mike, do you want to just say that we'll post that in the forums?
Yeah, I'll just post it.
good.
Okay, great. Thank you. Dallas.
Okay, I'm off mute now. I haven't been doing anything exciting. I just, little utility project I did for Rick Manhattan yesterday. I haven't even given it to him yet. I made another adapter for hoses, for which seems to be the most common use for a 3D printer. But the thing that's different about this for me is first time I've designed in Fusion 360. I did the design in 360 and fought my way through that learning. I'm used to SketchUp, but I was successfully able to design it in there and send it directly to my printer. That's pretty nice, but I've still got a lot to learn in 360. That's it.
Susan seems to be, at least in the corner of my screen, giving you accolades for using Fusion 360. I think you have another enthusiast out there. Anybody else here a Fusion 360 user? I mean, I am. I'm not very good, but
Yeah.
okay.
Too.
Mike, okay, good. The other 5 of you who are muted, if you happen to be a Fusion 360 user, would you let us know? Because maybe we'll hold one of these sessions around that topic. There has been an interest expressed in doing that. We got about 7 people who said they'd be curious to talk about Fusion 360 and have a user group about that. Tim, are you a Fusion 360 user?
Well, I've been playing on it in the background because I mistakenly thought that's what the session today was. But I will become one rather quickly. I can see, so my background is as a mechanical engineer. I've done a lot of design in Creo, Pro Engineer, a little bit of SolidWorks, but generally in my professional career, SolidWorks wasn't powerful enough for me. Especially in the early days.
Wow.
So in large advanced assemblies and some of the higher level top-down design and parametric approach. Fusion 360 looks really good to me from what I've seen so far, so I'm looking forward to it. It is parametric, and I won't go into too much detail what that means, but it's really great for making edits, making changes, specifying things, but it is a different way of thinking. So you can specify and edit dimensions at any time. You're not grabbing and stretching things or trying to snap to grids and things like that. So you put in the exact dimension you want, or in some cases even a formula. So I'm excited about that. With regards to the 3D printing, again, my experience has been professional, so I'm kind of new to the hobby side of it. I've done very little of what you call 3D printing to fused deposition modeling. Most of what I've done is SLA, SLS, and Project, which are much higher resolution, but too expensive for our applications. And, but I did want to comment, when you're talking about drying out filament, while I don't have direct experience with filament in this case, I do have experience with drying out materials, plastic materials for production, including injection molding. And the approach is actually the opposite of what we were discussing earlier. So if you put it in a cold environment, when you bring it out, it's going to condense. And also the absorptivity of the material is going to be higher at the colder temperatures. So really you actually want to have it in a warm box. And if we wanted to do something like at the club, we could still use the fridge, but we'd want to just scavenge heat off the coils at the back, ironically. Find some other source of heat, maybe, you know, an old-fashioned incandescent light bulb or something in a box. But just keeping it warm will dry the material out internally, because it's internal moisture, not surface moisture, that I think we're probably most concerned about.
Yeah, and I don't know how moisture affects dimension, but one of the big issues in the early days of 3D printing was inconsistent diameter of filament, and how you have a consistent flow rate presumed, but as filament gets thinner or thicker, it affects the flow rate and affects the quality of print. If moisture is absorbed, does it make it thicker? If it gets hotter, does it expand, cooler, contract? I don't know these things, but I've not really heard of people doing anything with regards to temperature to preserve their filament, hot or cold. It's more been in the direction of moisture avoidance and desiccants. But we've got something we can at least start with, which is that project. But just going back to what you were saying, Tim, you seem like remarkably familiar with this space in terms of the design aspects in particular, when you were talking about even SolidWorks not being capable of doing what was needed in the professional environment. Are you curious about Fusion? Are you in the process of learning it?
I am in the process of learning it, yes. And I think it's got a reasonable amount of power. And most of I'm trying to be semi-retired right now. And so most of the projects that I take on are a little simpler. Mm-hmm. And I'm thinking it may achieve what I need to do. And rather than go to SolidWorks, which would do a great job at the stuff I'm doing now, I might go as far as Fusion 360, because it's a little bit more affordable for
right.
the activity that I'm doing now. And I think it's great in this hobby space as well.
Hey, just out of curiosity, in this volunteer-centered organization, have you ever considered teaching?
Yes, I've thought about it. But I've got to get good enough at Fusion 360 first. I used to teach. I taught AutoCAD back in the 90s, and in the 2000s, I taught Pro Engineer on contract to the company. So I do have a little bit of teaching experience.
Cool.
And while I'm not as smooth a teacher as you are, I would look forward to being able to contribute anything I can.
Thank you, Tim. That's awesome. Did you have any projects? Do you have a 3D printer currently, or is there a project you've done lately?
I don't have a 3D printer right now. Any projects I'm doing right now are too high resolution for that. But this was kind of going to be my introduction into 3D printing. Cool. To use the club for that. I've done a lot of the laser cutting as I explained to you, but 3D printing with FDM. So
great.
I don't have much there, sorry.
There's a note in the chat box from Susan. It's a very self-serving message. She says, Tim, I'm looking forward to signing you up as a teacher or to teach.
Well, stay on me and nag me till I get the level of expertise that I feel comfortable doing that.
That's great.
Clearly, I'm not there yet.
That's great. Thank you, Tim. Julia didn't make it, it appears. I'm going down the list here. Jane, have you been doing anything with 3D printing? You have anything you'd like to contribute?
No, I haven't. I'm just listening. My house is still under construction. Mm-hmm. So I have been on top of myself since October. So I have no space, which that's why Susan has been storing my CNC. And Susan, you are more than welcome to use it. Thank you so much. But no, I'm just listening. I'm learning as much as I can and just waiting for my time to come.
Well, and Jane, that's also what this forum is about. Not everybody has to have something to say or share, but just by being here, they can learn. So I'm glad you're here and welcome.
Thank you.
Susan, you're up.
Okay, am I unmuted? Damn it. Hold on. Okay.
Yes,
Now
we
I'm
hear you, Susan.
unmuted. Can you hear me now?
Yes, we can.
Yes, ladies.
Okay. So I don't know who all was on the email chain, but I've been printing with NinjaFlex on my little 3D printer. So there's a part for a knitting machine. It's actually not a part, it's a consumable, which is a wax cylinder. And it fits on and the yarn runs over it, and it just helps the knitting machine work better. And these knitting machines are from the 80s and they don't make them anymore. And they don't sell the wax cylinders anymore. And we were looking for a perfect fit mold to make the wax in. So I just used NinjaFlex. I used Fusion 360, which works great because I got it, the wax cooled strangely the first couple of times, so I had to adjust the measurements. And I also had to adjust it so I could get the wax out of the mold. So yeah, Fusion 360 was great for that, and I would use it again.
Can you show us the flex again? That's kind of remarkable. You don't normally see that with ABS, PLA, and anything else.
Stuck the thing in there. So the whole thing is made out of flexible, it's called NinjaFlex is the brand. You have to run it a little bit hotter. I think it was 225 I had to run it at to get it to melt. And I found, so I have an Ender Pro, so I have that magnetic black bed. This sticks to that like glue. So I use the blue tape on it for, so I could actually get it off the bed. But other than that, and I need to get some settings right for, there's a little bit of extra fur coming off of where it changes position.
Right.
But
very cool.
That's it. I need to set up the fire protection thing. I wanted one of those for a while.
Well, Mike's going to get us the solution there.
Yeah. I have
right,
a camera on mine, so I just keep like obsessively watching the camera to make sure it's not caught on fire.
Right.
It never has, but it's in my shop is part of the garage off the house, so I don't want it to burn down.
So that is a good opportunity to mention a second thing we did with the 3D printer. When Mike came in and dealt with the fire problem that could be a problem in overnight prints, we still recognize that prints fail, and when they fail, you just kind of want to be able to stop them. So we now have an additional solution for the 3D printer in the shop, which just makes overnight printing all the more confidence inspiring. And that is that when you're at the printer, on the cover, you'll see a post-it that talks about an app you can download to your phone. And with that app, you are able to monitor from anywhere the progress of your print. And frankly, now you can monitor it at a very nice angle because Paul installed a platform so you can look down on your print as it's going. And if you do find that the print has failed, you can, through the app, turn off the printer. So now we have a solution that keeps the place safe from fire because of Mike's fire prevention or fire triggering power strip. And you can also choose to turn it off if your print fails. It loses contact with the bed or something happens to throw it off. Through this app, you can monitor and turn off a print. So that's just an additional thing, and the details are on a post-it on the front of the FDM printer at the shop. Any other questions for Susan about NinjaFlex or whatever?
Yes, I do. Susan, what do you use for bed temperature with the Ninja?
I was using 55 degrees on the bed.
If you didn't use a bed, just shut off the bed, would that change anything? Would it not stick as mad?
I don't know. I'd have to try that. I run without a bed that had any heater in it for a long time, so I'm really excited to have a heated bed. But I should try to turn it off for the NinjaFlex. That would be good.
Yeah, that'd be something to experiment with. I hate messing with blue tape.
Yeah, I don't use it very often anymore now with the heated bed and the Ender Pro. Do you guys all have that? It's the the magnetic thing that sits on your bed and you can just pull your whole print off and then flex it and your print pops off. That's great. I love that. So
it is interesting question, Dallas, because, you know, PLA, before we had heated beds, people would just print onto a flat surface, not heated. And now that you do have heated beds, at least in my case, I usually will print to a heated bed of 55 or 60 degrees C. So maybe NinjaFlex is similar in thermal tolerance on the bed level. But yeah, Susan, if you could let us know, that'd be great.
I'll try it. And if you're wondering at the start, I was fixing my dog's toy.
Good job.
I was sewing. This is the only dog toy we have that doesn't, it has a squeaker in it, but it squeaks at a dog level.
Oh, so
Humans I can't hear it squeak. It's the only video conference friendly dog toy I have. So, and he ripped a hole in it and shredded everything out. So I was trying to fix it.
Excellent. Now, if we look around the screen, there's only one face that hasn't said a word. Who would that be? Jim McGeehan. Jim, go hiding, will you? Jim, have you anything to share on the 3D printer?
Yeah, I'm just sitting in. I haven't done anything on the 3D since I did the class, but I thought I'd see what was going on in the area.
Okay. I guess I just realized that I didn't actually go. So, Jim, if you didn't have anything, I'll go ahead and go.
I got nothing for you.
Okay, that's fine. So one of the things that I've been doing is, in the context of the COVID-19 virus, one of the things that's needed is face masks. So I've been kind of trying to figure out what I can do, looking at prototypes, reading what people are doing. This is also one of the reasons I'm sharing with you what I'm about to share with you is I want to show you two other features, which are I can choose to show you my screen. And so if I go to my browser, I can take you to some pictures that I want to show you. And so this right here is a design from a company called Copper 3D. It's not really practical and it's not yet the solution, but it is an example of using 3D printing to come up with a mask. Now, the version that I have made is not anything like this. And if you go to the website, you actually don't see a version like this that contours nicely over the nose and has those angles towards the front. So even if you are interested in doing this, what you can do is on the previous screen, I think it was, that you can download the STLs right here, download STLs, so you can print it. And when you do print it, what you do is you end up with a series of flat components. You can see that this is the shape you get. I actually have this part right here is a screw-in cap, and there's also another filter inside. So this is where you'd put a filter component to get, I guess, like N95 compatibility or better. And yet the thing when it folds, you fold it back like this. You have some ear straps on the sides here, so you could put a strap behind your ears. But you can see that when you put it on, I don't know, it's not contouring over the nose yet, and it doesn't say yet how you get this thing, this bottom portion, to actually stick to the bottom of the part that wraps around. So you can see that it does take a contour, but it's really just a prototype. So this really wasn't a solution, but it's an example of just using 3D printing, at least at this stage, for prototyping purposes. So I thought, what else could I do with 3D printing in this context? And I went ahead and kept looking. The next thing was what's being done by the Prusa organization. They're just getting involved in some worldwide prototyping initiatives. I have not built this one. A friend of ours named Doug LaRue has. This requires that you do some printing of some head straps and a base strap, and then you just laser cut a very thin sheet of plastic and put it all on. You can see that on the next slide, it's not meant to be the sole solution. They're using it in conjunction with face masks, but it does add an extra barrier of protection. And so that's something that I may well try prototyping, but haven't yet. So I was trying to figure out what else to do. This is a mask design that you can see in Thingiverse that uses a 3D printed nose piece, because at least the masks that I've made so far don't do a good job of contouring over the frame of the nose, over the crown of the nose. And so here you can print different shapes that would be inserted into this generic mask for good fitting on the face. Oh, this is the work they're doing on my street this morning. Never mind. Let me show you one other thing, which is I have been also trying to do things with sewing, which is just a little more practical, but it's in this theme of face masks. And I got the idea from that one 3D printed nose piece, because the ones that I've made did not contour nicely over the nose. So I was getting steam up into my glasses, and I realized that I was also bringing in steam from elsewhere. So this is a design, one of many out there that you can make. This one is not a good one because the materials I used were too thick, and I couldn't get the right number of folds, so it would contour around my chin and therefore at least get a good seal around 3/4 of it. Over the nose though, it was something that still was letting the steam up into my glasses. So going out into my shop, I have just sheets of metal, and I was cutting these 2.5 inch long, 1/4 inch wide little strips that I will then sew into the seam over the nose, so you can then bend it and have it maintain the shape over your nose. Now, this is not a good enough solution if it's just layers of material, but this is the design right here, and it has a pocket that you can insert a filtration material inside. And so in an attempt to figure out what we could add to the inside of this that would give it something along the lines of the type of filtration that is needed for the coronavirus, I found that certain vacuum companies make bags that have a certain HEPA standard of filtration. And so I bought a whole bunch of vacuum bags that I'll then cut to fit inside of these masks. And if I get the right seal, I'll end up with something. And the whole idea here is we have a guy in our community, probably a bunch of people like this, but it was Michael Lewis who was trying to figure out what we as an association could do in helping out with the lack of supplies during this time of crisis. And he was asking, for instance, could we maybe ask members to contribute masks? And there are probably some of that we can do, but how can we also perhaps serve another role? And so he wants to gather up a bunch of things made by people who are sewers, gather up masks that are acceptable to hospitals for distribution back to the hospitals, and maybe use the fact we have this large community to get the word out. And so what I'm trying to do is just make a small contribution. My daughter is a nurse. I know what she's going to be going through, and I just wanted to make my own small contribution. There are many, many initiatives right now online that if you're at least curious to see if there's something that you can contribute, there are lots of things to jump on board with. And this was simply my little example of that. So that's it. Any questions about my 3D printing project?
Good one. So Travis, you want to make sure with the filtration material that you try and put in, if you like cut bags or something, make sure it doesn't have fiberglass in it or something else. Some of those things that people are recommending to cut up are not something you'd want to be breathing through close to your face. Yeah. Some of the filters. I don't know, I haven't researched it. I just saw that. I'm like, yeah, I don't want to breathe fiberglass.
No, this was actually from a medical professional, this particular bag. They said it was a HEPA NH11 certified material, and that she said this was a nurse or a doctor. She said this was the right kind of thing to use. So good point.
Okay, good. Just don't use just anything out there.
Yeah, right. Any other questions? Okay, good. All right, so we've gone through a little over an hour, and the intention was to do exactly what we did. I think we got some wide variety of insight here. I personally found that this was pretty rewarding and enjoyable. As I said, this has been recorded, and so I'm going to be putting it up into our forum area. I will send you folks invites to join in that discussion. If any of you have something from this call, which you can post, be it your NinjaFlex prototype, or be it a shoulder blade, something we all do, right, on a regular basis, then please post it. I'd really like to grow that community and make it work. Let me see, I had a couple of other notes here. I wanted to get you folks, well, before we go on, anybody want to say anything else before we wrap up? No? Dallas? Okay, so one thing that happened recently was Dallas did, first off, came up with the idea of using this within our community to bring groups of people together to advance the association's benefit, the shop benefit, to help our members in isolation, you know, just to keep the community thing going. And he held a session a couple days ago on a vacuum clamp system that he has built and implemented. It was really good. We got to see his shop. We got to see his project. We were able to ask questions of him. It was in a more sort of formal setting than this floor of equals. It was more like there was a presenter, so we had to use a little bit more of the tools. There's another one of these coming up on Friday at 10. Gary is going to be sharing what he does with epoxy. You probably have seen some of his golf clubs or jewelry that he does with wood and epoxy. It's just gorgeous stuff. And in particular, he's going to be talking about the finishing of it. So that, for me, is going to be something I've always wanted to know more about. I learned a bunch from Mike recently. I'm going to be learning more from Gary on Friday. And that is something that's coming up. But we'd like to be doing more of these kinds of things. And I wanted to get your feedback. There are 4 ideas that are kind of been floating around. One was the Fusion 360, and correct me if I'm wrong, but I sort of got a sense that people, even just in this group, would be interested in the Fusion 360. And I know of another 6 or 7 elsewhere. Sound like a good topic? Yeah, okay, I got a thumbs up from Dallas, okay. I got a real life thumbs up from Mike. Got a thumbs up from Jane. Okay, good. Another one is Susan was thinking about how some of our classes that would otherwise have been taught in the shop, if they don't require use of a tool, maybe it's something that we could pull off via a system like this. Again, in a more formal way, but still doing a class in this Zoom context. And hello, Kitty. No, Susan was paranoid that it was one of her cats. Lightburn 201. That's a class that was dreamed up by Alan Lewis. And the idea in that is to go beyond the superficial that we deal with in the laser intro class, where it's just a workflow on how to bring in designs, prepare them for output. It's to get more into the designing features and other aspects of the software. That's something that's software based. It's something we could all join in. And as a prototype, we were thinking about using that as a class. Would anybody here be interested in that sort of a thing? Thumbs up? Yes, no? There, got a real life thumbs up from Dallas this time. Real from Susan as well, okay. Paul, yeah, okay, good. Tim, oh, that's all around, that's good. Susan, I think we've got a winner there. Another one was for those of you who have been into this diode laser. You may remember a SIG meeting a couple of months ago, one of the Saturday morning digital SIGs, where Alan brought in a small 15-watt laser. And from that flowed a lot of enthusiasm, which we kind of harnessed just about the time that China shut down. So what I'm telling you is that we have upwards of 20 people or more who have ordered a laser, small diode laser. It cuts 6-inch by 6-inch square. It only has the equivalent when you compare it to our lasers and how we measure power in the shop. It's about a 5-watt laser, so it's really primarily for etching. But there's a bunch of people anticipating getting theirs. We have a few of them in the community to get people around that, and people who might be interested in that to join in would be another topic. So Does that, anybody here in that group? I know Dallas, you are. Yeah, okay, Jane. Anybody else here buy one of those diodes? Mike, did you buy one of those? Paul did, yeah, right, okay. So that's just another topic, so we'll probably do one around that. And that again would be more like this, show and tell learning, maybe a demo or two in the mix just to give a sense of it. And then Susan was thinking about what other classes we might do. And one of them that maybe we could do is the 3D printing class, but not for certification, just to go through all the principles and software and workflow so that those who participated in it, when we got to the shop again, maybe in an hour or two, we could actually do the whole class because everybody had the background. And those of you who are sitting there at home wanting to learn a new tool could maybe buy one and benefit from a class like that. And then through subsequent conversations like this, get questions answered. Does a 3D printing basics class sound like something that would be of interest? Because you guys are all so expert already. So those are 4 ideas that we had, and this is not meant to be pouring out of just me and Dallas and Gary, the people who have been doing. We would like this to be a tool for anybody who has a woodworking passion that wants to get a group of people together. So for instance, I'm going to be approaching each of the 12 people who are going to be at the last general meeting who wanted to start up SIGs. So everything from laser cutting to epoxy to caning, etc. Maybe they'd like to set the stage here. Anybody who wants to conduct one of these things should be able to. We'll take care of the heavy lifting of, well, I guess since it's understood now, it's the light lifting of setting up the technology. And then the heavy lifting is done by the person who's just going to conduct the session. So if you guys find yourselves being maybe one of those who'd like to conduct one of these, let Dallas or Gary or me know, and we can help set the stage for that. Because in this time of isolation, it's a way to bring people together. And I've been staring at 4 names and 6 faces for over an hour here. This is a version of social. Any thoughts or comments from anybody before we call it an end here?
I may have, this is Darryl, I may have missed the NinjaFlex specs, but I'm always had a hard time printing NinjaFlex.
Susan, can you give them a little bit of a comment again, just so we can hear that?
I've always had a hard time printing NinjaFlex. And so if you can share the, the secret sauce, or if you can have a class on NinjaFlex, that would be great.
Ah.
I can definitely, we can do one specifically on flexible printing. I don't have a ton of experience with it, but it's been getting better every time I try it.
I mean, I looked at what you showed and it looked pretty good. I mean, I've never been able to do that. Yeah, I can squeeze it, but
that's success right there.
All my print.
I initially tried to do the mold in PLA, but I couldn't get the wax out of it easily enough. And this is for knitters who are probably in their 70s and 80s.
Right.
And they're actually going to use beeswax to fill them all up. So once I get a prototype that's good, we're going to make a tray of them, and they can just fill it up a tray. And they need to be able to pop the part out easily. So I originally got this for gaskets for outdoor electronics to keep the actual biological bugs from getting into my electronics.
Could other people comment on whether when Susan speaks, it's buzzing in their speaker?
Oh, I'm sorry.
No, I just want you to.
It's bad. It's bad. My speaker's bad on my laptop. My microphone's bad as well. So I'll get that fixed.
Cool, great. Because I expect we'll see you on a lot of these things. Any other comments before we end?
Thanks for doing it.
Oh, thank you guys. This is great. I really enjoyed it. And the stories you had, I wanted to hear them. I enjoyed that a lot. Thank you. All right, with that then, I will end this.
Travis,
I'm sorry, Jim, go ahead.
I have a question. 10 minutes ago, you showed how you were able to link to your computer screen, and we looked on the web. Is that available to all of us? And if so, what did you do?
So let me ask, because I'm not sure whether I'm looking like someone who's running this or as a participant, but on my screen at the bottom, there is a green share screen button. Is there one on yours?
Yes.
Okay, so a lot of people here see at the bottom of the screen, when they take their cursor down there and the margin pops up, they see a share screen button. When I click on that, I am shown all the screens that I have available. And when I go to the browser, I'm able to, here, just as a for instance, you can even do video here. So,
okay.
Just a second here. I want to show you guys so that you can think of in terms of other media that you can use. There's video as well. And I had to, oh well, never mind. I'll just double click on something here.
Okay, so it looks like it's available to all of us should that be needed.
Yes, yes, it sounds like it.
Good.
So that's just one more option when people are sharing or presenting. Video, you can show your video, that is to say video is recorded, video from your camera, and also screen of any application that you have. Okay. All right, anything else, anybody? All right, thank you very much, everybody. We'll be seeing more of these things. Talk to you later.
Thanks a lot.
Bye.